Okay, it's me again. I just figured out that having all these capacitors like this and lowering the resonance frequency, I also lowered, of course, the voltage across the coil when not in resonance. What I mean by that is that for anything interesting to happen, if I put the battery and the rectifier in series with the resonant tank, the coil has to give more voltage without being in resonance than the battery plus the voltage drop in the rectifier. So as you can see, I have taken out some of these and been trying other frequencies that is getting higher as I take them away, and now I'm up here with a frequency at 191 Hertz. Right now I'm running at 171 Hertz, and this is across the coil, this is across the battery, and this is the resistor to the battery, so we can see if it is charging. So let's connect again. Now there's another thing that is interesting. If you look at the voltage across the generator coil here, you can see that the motor coils are affecting it as well. I'm turning it off now, like that, and turning them on again. So you can see there's quite a jump when I turn on the motor. So the motor coils are leaking into the generator coil. So that makes me think about the splatter coils that Conehead was showing. Anyway, now as you can see, the coils are now giving more voltage than the battery plus the voltage drop without being in resonance, and we're just below the resonant frequency. And now I will connect the capacitor like that. Okay, as we approach resonance, and I will also connect the battery in parallel like that. Okay, and you can see the current going into the battery, and the battery is starting to charge. And I will try to keep it at this frequency. And so this is in parallel. We are charging off of the voltage of the resonant tank. And by resonant tank I mean the capacitor and the coil being in resonance. Okay, so it's going up. I'll let it go. The voltage on the battery is somewhat higher, and then I will connect it in series instead. Okay. Well, you got a feeling of the rate now that it's charging, I guess. And now I will connect from parallel into serial. Okay. Like that. Okay, there's another waveform across the resistor, and you can see that it's charging quite rapidly. And we're going too fast now. I have to slow it down, like like that. To be in resonance. Well, what I think is resonance now that maybe the parameters are changed because of everything, of the battery. It seems like the frequency might have gone up. When I look at the voltage across the coil, it's rising quite rapidly, and across the battery. Instead of 191 being the frequency, we are now at 198. Let's connect it in parallel again. See what happens to the battery. Okay. Like that. I think I'm going to slow it down. We're now at 202 Hertz. I'll go down to 191 again. There. But it's still not charging as well as when in series. And the waveform looks different. That's quite interesting. Now I will turn off the motor coils and we'll see what happens to everything. Like that. We're still above resonance frequency, approaching it now. This is about resonant as it can get, I think, and now we're below. Okay. And now I'll put it on again, and I will switch to series mode, like that. Just above the theoretical frequency of resonance, and let's turn the motor off and see what happens to the waveform and everything. Like that. So I guess there's some sort of resonance between the motor coils and the generator coils as well. Maybe. That's interesting. Okay, thanks for watching.